A very good afternoon to all of you. Today's lecture is on urban land use planning and classification. So, this is a very important topic for the lectures that you are going to listen. And this is the premise of urban planning. So, let us begin with the lecture and understand what land use is, what is urban land use, what is the difference between land use, land cover, how we go about with classification schemes, and at the end, how we are going to define a classification system. So, let us proceed. What is land use and what is land cover? In general, we use all these two terms interchangeably, but we need to understand that there is a very important difference between land use and land cover. So first, let us understand that land is a resource, and resource is not vast, it is scarce. What is the difference between land use and land cover? Let us focus on that now. Land cover and land use, when we say LULC map, we use the terms interchangeably. But what is a land cover? A land cover is the natural vegetation, water bodies, rocks or soil, artificial cover, and other due to land transformations, which are natural in nature. However, if we associate an activity with the land cover, it becomes a land use. So, by definition, the activities, human activities, and the various other activities which are carried out on this land cover can be regarded as land use. So basically, we can categorize the two definitions by this, that the land cover refers to the type of feature present on the surface of the earth, the biophysical features on the earth. There may be many land covers, for example, forest, vegetation built up. But when a human activity or a function is associated with that land cover, it becomes the land use. For example, what can be known as a land use? A residential land use, a recreation. For example, open park area, it is open land or green land, but the land use is recreation because an activity has been associated with that land cover. What is the importance of urban land use plan? Now, as urban planners, we essentially understand that a master plan has to be prepared, and master plan is a vision document for any city. So the premise of making a master plan is that we need to know the existing land use pattern. The course in the lecture, we will understand that how and why urban land use plan can be prepared, how it can be monitored, how it can be helpful in predicting the future master plans, future land use plans, and how we can assess it. What is the importance of land use plan? Let us focus on that. It is important for the order and regulating the land use in an efficient and ethical way, because we have plenty of land available, but how are we going to use the land? That is what land use plan is going to tell us. So it is very important for us to have a plan for it, a land use plan. Then the parcels are available, but we have to, according to the utility, divide the parcels of land. There comes the second utility. Third, while preparing a land use plan, we need to understand that a standardized pattern or a standardized system has to be followed before delineating a land use pattern. If I am following one land use plan pattern and someone else or some other government is planning for some other land use pattern, the two will not have sync and all planners will not come to a consensus and understand the land use map. So it is essential that all over the country at least, or all over the state at least, a typical standardized pattern can be followed. Of course, it has to be accurate, it has to be up to date, it has to be standardized and can be comparable. Why we are emphasizing on the land use plan and emphasizing on its accuracy and updation is because we make a plan for approximately with a vision of 20 years. When we make a plan with a vision of 20 years, that means for 20 years we are not going to change the plan. And if today's plan is not accurate, the vision will also be inaccurate. Hence, it is essential that today's plan needs to be monitored and it should be made accurately, in which remote sensing and GIS can be of great help. So if we summarize the slide, we can say that urban land use plan is an inventory of all parcels of land owned publicly or privately, developed or undeveloped land. I hope all planners will agree to my statement. Now earlier, conventional methods which we used to use was, we used to have chain survey methods, old mechanical theodolite service, vernier theodolites, paper maps, but now we are using remote sensing, GIS, GPS, total station. So these modern methods for survey has improved accuracy and the ease of making maps. So once we have seen that there were certain conventional methods and once we have seen that there are certain modern methods, obviously there is a niche over the conventional methods of the modern methods. So let us understand that why the conventional methods could not be used so widely. Still, in fact, we are using the conventional methods for surveys, but soon we are going to switch over to the modern methods, and it is going to help us in making our maps more accurate. So let us understand that what are the disadvantages of using conventional method. The basic disadvantage is that once a map is prepared over a sheet, it cannot be reproduced at any other scale. As we all agree, it takes a lot of effort to prepare a hard copy or a hard map by digitization by hand or by digitization where human effort is required. But once it is digitized, it can be reproduced on different scales. Now, why I am emphasizing on different scales is because a land use map of a city is prepared on a different scale. However, a regional map will be prepared on a different scale. The requirements of both these maps will be different, and the planning of both these areas will have a different approach to be followed. Hence, it is essential that we have different scale maps. So once we have a different system apart from the conventional system, we can help in reproduction of the maps. Then, once the map is prepared, whatever attributes you are filling to that particular area can be written by hand over the hard copy map. But the attribute data that you want to fill in later on it is not possible for you to keep on writing everything on the map. So once a GIS map is prepared, once a database is prepared, you can keep on adding more and more attribute data to that, keep on adding more and more fields to that particular data once the base map is prepared or once the base layers are prepared. Then the decision making process obviously on older map is very cumbersome because you have to read entire information one by one because all the information is present on the map. You cannot filter any information and see only the information that you want to see. When a lot of information is available on the map, the decision making process becomes cumbersome and probably it may lead to wrong decision making. And when we are talking about decision making, we are actually referring to what? We are referring to the future growth scenario or the present growth scenario. Low temporal resolution, as I said, once the map is prepared, once the survey is done, it takes a lot of time for doing that survey. It takes a lot of time for preparing that map. And you cannot reproduce that map again and again. You cannot, after each year, you cannot prepare another map. This is very difficult. But with the help of remote sensing and GIS, that is possible. Each year survey is not required. Each year growth pattern can be analyzed using remote sensing data. And then large number of measurements are required to prepare a map when using conventional method. However, if we are using the modern methods, we are going to have a satellite data, and the built up area or other areas can be extracted using digital image processing technique. So we have already discussed that modern methods, we are going to use GPS, global positioning system, we can use remote sensing, and we can use GIS, that is geographic information system. What is GPS? GPS receives and records the satellite signal. GPS receiver can be attached to computer and automatically plots the points. Remote sensing is definitely a very economic, a very cheap technique of transferring and extracting information which also means processing and analysis can be done apart from the preparation of the database. As we have already discussed the flaws of conventional methods, we now come to understand what are the advantages of the modern methods. We can map at any scale which is understood. A full-fledged GIS database can be prepared and all the attributes can be attached to this data. It is very economic and rapid method, and it is the only practical way to obtain data from inaccessible regions. Very, very important point, because not always you can go for survey to all the regions across the nation. You have to have the data of those regions which are inaccessible. Here remote sensing plays a major role. And of course we have high temporal resolution, as I have already discussed, that each year data also, if you require, you can have with the help of satellite imagery. In fact, various seasons also you have different imageries. So if a person is interested in Rabi and Kharif crops and extraction of that, he can have it with the help of satellite imageries of two different seasons across the year. One another important term which is associated with land use and land cover is space use. Now, why we are interested in space use? Because cities have been sprawling. Cities are sprawling across various dimensions. Basically, we understand sprawl in two dimensions, and when we say we are mentioning about sprawl, which means beyond boundaries. And what are the boundaries we are discussing? The boundary is the municipal boundary. So whatever is beyond the municipal boundary is considered to be sprawl. So apart from the two-dimensional sprawl pattern, which can be analyzed using a satellite imagery, we also need to understand what is the vertical dimension of this growth. So for that, space use is very important. And also, where mixed land use patterns are prevalent, space use is essential in understanding the changes in the land use pattern or the mixed land use pattern. So what is helpful in space use? We have various 3D models. We can have the aerial photographs where anaglyphs are prepared, and we can have a 3D view of the area. The depth dimension and the height dimension can be perceived if we have a stereo image. Then high resolution stereo pair, various high resolution stereo pairs apart from aerial imageries are available. High resolution stereo pair imageries means the satellite stereo imagery, which of the same area from two different locations, the same area has been accessed, and you can have a look on that area in stereo. That means the height and the depth dimension can be understood. Then 3D can be prepared. DSMs or digital surface models can be prepared using these stereo pairs. Then we have LiDAR data, light detection and ranging data. This is a point cloud data. Point cloud data, high dense point cloud data, which will help us in extracting the vertical dimension of any footprint. It can be building footprints if we are interested in urban areas, or a tree footprint and the density of the tree, the canopy of the tree, anything for that matter, where the three-dimensional structure of the area is associated. Then we have close range photogrammetry. Close range photogrammetry is a part of terrestrial terrestrial remote sensing, where cameras are helpful in taking point cloud data of the entire facade of the area and built the 3D. The ground survey, of course, is helpful in the ground truthing, without which a 3D is incomplete. So space use is important because today we are talking about redensification, we are talking about de-densification. Hence, the vertical dimension is becoming more and more important to us in analyzing the growth pattern of an area. And especially if we talk about the core city areas, because core city areas generally de-densify. Now, let us understand, after understanding what is land use and land cover, what is classification and why it is important. Now, when I'm talking about a piece of satellite data, I'm sorry, not a piece of satellite data, an area which is captured by a satellite in a satellite imagery, then we can see one area. So that one area has number of features associated. Now, what do we do of that features? What do we do of those features? We have to classify them, or rather I would say group them into similar feature categories, so that we can identify same features and club them together into one category. So nothing but subdividing a group of objects into two or more groups to arrange it into objects, arrange it into classes according to a system or principle. Like we have discussed about the standardized pattern. It has to be standard in nature but clubbed together into classes. A suitable framework, and definitely it has to be economic and based on a economic activity or a function. So broadly, if we speak, there are two types of classification. One is hard classification and the other is soft classification. We will discuss both the classification systems one by one. Hard classification, generally pixel based classification. As we all know that a satellite imagery is made up of small pixels. Pixel size governs the spatial resolution of that imagery. The lower the pixel size, the higher the spatial resolution of the imagery. For example, if I say that 1 meter ICONOS data, that means 1 meter by 1 meter is the spatial resolution of the imagery of ICONOS sensor. Second, if I say worldview data of 0.5 meter resolution, that means 0.5 meter by 0.5 meter is the pixel size of worldview 2 imagery. So which is better out of the two? We will say worldview 2 data is better out of the two. However, other resolutions also play a major role, for example radiometric resolution. But then in terms of spatial resolution, we will see both of them. So coming to pixel based classification, which is a type of hard classification, we are assigning a class label to each pixel resulting in manageable size of classes. So what we are doing, the spectral value or the spectral signatures of the pixels are identified as training sets, and the entire satellite imagery is then classified into group of pixels having or sharing the same kind of spectral properties. So this is what we do in pixel based classification. Second is soft classification. In soft classification, we adopt a fuzzy logic. When we say that a satellite imagery is divided into certain pixels, now each pixel is not important to have only one spectral signature. It can belong to water category, it can belong to water and urban category, and can be a mixture of two or more classes. So how do we define that pixel to one class only? Which was happening in pixel based classification. So what we do in fuzzy classification is that each pixel is further subdivided into the percentage of its purity and its percentage of the pixel belonging to a certain category of class. Object based image analysis is helpful in providing the soft classification, and image segmentation can be one way of doing object based image analysis. Another important thing which is important to understand apart from hard and soft classification is that we also classify the imagery with the digitally by digitization. Now, when we are doing digitization, image interpretation is a key towards digitization by hand. So we will now understand the image interpretation principles and the guidelines for the classification system. And after that we will discuss the image interpretation keys, because before digital classification it is important to understand that how we will make a closed land use map, not a land cover map. And there are various levels of making land use map also, that also we will see further. So the classification system should not be applicable only over a smaller area. It should be generic in nature and should be applicable over a large area. Should be able to govern different time periods. The minimum accuracy should be 85%. And what do I mean by 85% is that 85% of the pixels or 85% of the classes should belong to that class which it belongs on ground. Means what we have classified and what it belongs in the ground should be same. The nomenclature, the definition and framework should be easier to understand, should be flexible, and the aggregation of similar or multiple land use classes should be there. Now, before choosing a satellite imagery for classification, what we need to understand? We need to understand that for what purpose are we choosing the imagery. If urban growth pattern or only the built up area is our emphasis, we can choose any time data, any season data. If land surface temperature estimation is our feature of interest, then we have to choose a season in which the all the means the vegetation is also healthy, so that we can understand that what is the difference in the surface temperature over built up area and the vegetation area. So depending upon our usage, depending upon the use for which we are putting a satellite imagery into use, we have to choose the data. So we have different classification systems. We have level 1, 2, 3 and 4 classification systems. This is the USGS classification system from US. When I say level 1 classification, that means it is a regional level of classification system. And when I say level 4 classification system, it means it is a detailed level classification system at the local level. So in India, what we follow, we will discuss. This is level 1, 2, 3, 4 classification of USGS, where level 1 becomes urban or built up land. However, level 2 becomes residential, commercial, industrial. Level 3 becomes further subdivision of those classes. And level 4, it might go to level 4, it might not go to level 4. So in India, we are using NUIS, that is National Urban Information System guidelines for the classification system in India. The level 1 classification, which is helpful for perspective planning. When I say perspective planning, in many cities it is known as a perspective plan. Many cities it is known as a development plan. Many cities it is known as a master plan. However, perspective plan can be related either to a master plan or a regional plan. Built up land becomes your level 1 category. Level 2 category is either rural and urban. Within urban you have residential, industrial, commercial. Level 3 you have within residential high rise, medium rise, low rise. And within level 4, which means more detailed breakdown of these built up land or the residential, becomes apartments, flats, row house, tenements, etc. So this document can be downloaded from NUIS from Bhuvan, and the details of all these levels are given there, and the link is easily available on the web, so you can download it from there. So in detail, I have put on the slides where you can go and see level 1, 2, 3 and 4 classification system for all the land uses, for all the land covers. It is not essential that we go down to level 3 and level 4. In some cases, till level 2 also the classification is completed. Now, when we talk about classification, we need to understand that what do we understand by urban, what do we understand by rural, what is agriculture, what is forest, what is scrubland, wasteland and water body, and how it will appear on the map. So for that, image interpretation is essential. As I said, when we are making a level 4 classification system, we need to understand that it has to be very detailed. So for detailed digital or DIP, digital image processing is not going to be of help. We have to digitize each and every boundary and delegate it to certain category. So for that, image interpretation is a key. We all know what a false color composite is. A false color composite image is a representation of bands where we use red instead of red, green and blue, which is the standard RGB pattern. We use red, green, we use replace with NIR band. So it's like NIR red and green. Now, built up land, how does it appear on the standard FCC, standard false color composite? It appears whitish blue in color. So these are the keys for understanding within the image how the urban will seem. So this is RGB on the left, and on the right you have standard false color composite. So within the false color composite, the vegetative areas will appear red in color, and hence it will be helpful in understanding the vegetated areas. Cyan color represents the urban area. Whitish blue or cyan color represents the urban area. Rural will also be of the same color, but the only thing is it will be sparsely populated and the congregation of houses will not be in general. So by all the 7 or 8 principles, in general we have 9 principles of image interpretation which were already covered in the previous classes in image interpretation. Using all these image interpretation keys, you can understand in an image and identify the various categories of classification. In agriculture, light red or pinkish tone will tell you that it is agriculture. Let us look at this image. In this image of Rome, Italy, it is a list 3 plus pan fused image. You can see the agricultural field. How we have analyzed that this is an agricultural field? Because of the pattern of the agriculture field, proper rectangular patches. The water bodies are in blue color. The urban area is governed by cyan color. Similarly, a forest will be of dark red tone because the forest does not, it is closely dense forest will have dark red tone. Water body will appear dark blue as I showed in the previous imagery. Scrubland will appear light yellow to brown to greenish blue. Now, when we come to level 2 classification cannot be done digitally. Not always can be done digitally. However, attempts can be made. We all know what residential means. The definition of residential is given. Structures or apartments or row houses can be referred to as residential. Mixed built up area can have on the ground floor some other land use, whereas on the top floors it can be residential. For example, a mixed of residential and commercial will have commercial on the ground floor, residential on the other floors. This is a mixed urban area where you have vegetation also, high-rise development also, low-rise development also. Perhaps in some imageries you can see the slum development along the major drainage corridors also. Recreation will appear white to yellowish in color depending upon which type of ground it is. If it is a playground, then it will not have full growth of vegetation or grass over it, so it will appear white to yellowish tone in color because the soil will be visible. Similarly, what more recreation you can have? You can have stadia, you can have gardens, you can have race course. Stadia will be appearing with shape. You can identify whether it is circular or oval, and it will be located away from the residential area. So you can identify that this is also a recreation area. So this becomes a stadium. You can see the oval shape, and the golf course, you can see it's a big patch. However, only on the basis of image interpretation, an image cannot be classified. You will have to go on field and verify. We all understand what public semi-public is. Semi-public covers the educational institutes, schools, colleges. So by image interpretation, how are you going to understand that a school will have a playground associated with it? Then a big campus, a university campus, can be seen that it will have a lot of it will have greenery, then it will have playgrounds, it will have all sorts of playgrounds. So like this you can identify that this is a educational building. This is a image of Dehradun where a school is visible, in which two playgrounds are visible. Utilities and facilities cannot always be visible on the imagery. A high resolution satellite imagery is required for image interpretation. For vegetated area, as I said, in standard FCC, the vegetated areas are in red in color and can be easily identified over a standard FCC. However, there are other techniques called NDVI, that is Normalized Differential Vegetation Index, which can be helpful in differentiating the vegetated areas from the rest of the classes. Transportation corridors can be visible where we can see the continuity of the corridor. It will have a certain width and you can see that it is continuous in nature. A canal can be differentiated from a transportation corridor like this, that the canal will be absolutely straight. It will not have any turns, or a turning radius will not be there in canal. It is also classified within a built-up area. So the roads, as you can see, it's a image of LIS 3 and the roads are visible as I have shown in the figure. Similarly, in industrial areas, the industrial sheds or the tin shades or the plastic shades, big domes will help us identify that this is an industrial area. Moreover, the kind of roofing will reflect a lot of light and hence those areas will appear bright. Some more image interpretation slides where stadia in the first image. The second image is a crop growth pattern farm where irrigated by rotating sprinkler systems. The third image shows us the flyovers. So which methodology do we generally adopt while we are classifying an image? We use either supervised classification or we used unsupervised classification. Before this, I have told that if you are going for level 4 classification, that is a detailed classification, it cannot be done by digital image processing. Level 3 classification also cannot be done by digital image processing. Level 1 and to a certain extent level 2 classification can be done by digital image processing. That means the spectral signatures of the pixels can be attributed to a class and the entire image can be classified further. So for level 1 and level 2 classification system, this methodology can be followed, which I am discussing right now. For pixel based classification, unsupervised or supervised classification. When I say unsupervised classification, that means you are not knowing about the area, you do not know about the area, only based on the system's knowledge of the pixel spectral value, it processes the entire image, and it assigns the pixels different values, and later on the different values can be clubbed together to make classes. However, in supervised classification, we give training sets. Training sets means we know about the area, and based on our previous knowledge, based on our knowledge, we give each pixel, we assign a class. For example, based on our knowledge of visual interpretation, one pixel having dark red tone will certainly be associated with forest. Then one pixel associated with dark cyan color will be associated with built up. So likewise, we give all the pixels different, we give training sets to the image, and then we classify the image. So pixel based classification, we have the satellite imagery. We do image pre-processing. When I say image pre-processing, that means certain geometric corrections can be removed from the data. Some radiometric corrections can be done to the data, and then classification. If you do not have the knowledge, you can go for unsupervised classification. You can prepare the LULC map subsequently. Then you can do accuracy assessment. If you want to do apart from hard classification, you can go to object-based classification also. Object-based classification can be helpful in extracting features. Features, when I say, it is not going to divide the entire satellite imagery on the basis of pixels, but it is going to group all the pixels into objects. So object-based image classification can be helpful in extracting building footprints or tree footprints depending upon the usage on which we are classifying the image. As I said, that satellite imagery is very important for any image analysis or for any image classification. So for the LULC mapping, what is the requirement of the image? So let us focus on that. We need high temporal, high spatial resolution imagery. If we are doing growth analysis, we do not need to have high temporal resolution imagery. For example, we need to see what is the change in built up in the past decade. In the past decade means in 10 years interval. So if we have an image of 2003 and we have an image of 2013, we can easily identify the change in built up in these 2 years over a difference of a decade. Spatial resolution, how we are going to analyze the spatial resolution? When we say perspective planning 25,000 scale, 1 is to 25,000 scale, when I say local level planning 10,000 scale, 5,000 scale, 4,000 scale, it depends upon our usage. When I say that only high resolution satellite imagery is not useful for planning, I am correct in saying that because for perspective planning or for regional plans, we do not use or we do not need to have high spatial resolution data available to us. We don't need the information for regional plan. So depending upon the level of planning, we can choose the spatial resolution and temporal resolution of the imagery. So when I say for intra-level or ward level mapping, 1 meter resolution, and when I say city level mapping, 5 to 6 meter resolution, and when I say regional setting of the city growth pattern, we can have 15 to 30 meter resolution. I'll give you all the three examples. If we are doing or preparing a land use map for the city or ward mapping, what we can use is Cartosat 1 is giving us 2.5 meter resolution. We can have a fused image of LIS4 5.8 plus 2.5 meter resolution, and we can go for the city or ward level mapping. For city level mapping, that is 5 to 6 meter resolution, we can have our LIS4 image of 5.8 meter resolution image. For regional setting, we have 15 to 30 meter resolution, we can use list 3 23.5 meter resolution imagery, and we can do digital classification for regional setting analysis. Apart from our Indian satellites IRS-LIS data, we can also use Landsat imagery for classification, which is freely available on USGS Earth Explorer website. Temporal resolution, as I have already explained, decadal difference will also give you the results. Depending upon your requirement, you can choose the data. For example, urban sprawl is your focus, and sprawl does not change in 1 year. It does not. So if you need to know the sprawl of an area, you can have a decadal change map, which can be available for 10 years temporal resolution. So these are examples of how LIS3 image has been used for preparing land use land cover map for 2000 Indore city. .8 meter resolution. Detailed land use map for the city of Indore for 2000. These are examples of using our own Indian satellite data for the preparation of various detailed levels of mapping for the mapping purpose. And this has been done by not by digital image processing, not by any classification system, but by understanding the image, that is by image analysis or image interpretation. As I said, Cartosat and LIS data can be merged. Similar way, various other foreign satellites are also giving you high resolution panchromatic image and medium resolution. In fact, they also come in the same category of high resolution multispectral imagery, and both of the two can be merged together and can be used for image interpretation and for digitization of the areas. Detailed land use mapping. For this, high resolution satellite imagery is required, without which you cannot prepare a land use map of this detail. So within temporal resolution, we have the classification levels of level A, B, C and D. A is updated when change occurs within few days. Within 2 years is B. Within 2 and 15 years, C, and collected more than 15 years ago, it becomes D. So we can use C or D for our urban sprawl mapping. In the classification methodology flowchart, we had discussed about image pre-processing when I told you that different geometric corrections or different radiometric corrections can be applied. There is another correction that is very important, is atmospheric correction. Atmospheric correction is very essential, but for urban areas it does not hold much relevance. However, we can go for absolute or relative atmospheric corrections. It is a separate domain and can be discussed later. So how are we going to proceed with classification? Pixel-based classification. We have discussed about pixel-based classification earlier when I told you that it is a part of HART classification. Pixel-based classification identifies the spectral value of a pixel. It can be provided as a training set in supervised pixel-based classification and can be given as a the image can be given as an input to the system to decide on the spectral values and congregate, that is unsupervised classification. So let's procedure analyzes the spectral properties of every pixel within the area of interest without taking into account the spatial or contextual information related to the pixel of interest. Supervised and unsupervised are the two categories, as I had discussed earlier. Supervised classification, prior knowledge is required because you are giving training sets So once you are giving training set, that means you need to have at least some knowledge of the area, or you need to be a very good image interpreter. So for giving training sets, what do? We create a signature file. What do you mean by a signature file? A signature file is the value of that pixel. So likewise, we prepare several layers of training sets. Some belong to water category, some belong to forest category, some belong to urban category. It can also belong to high dense urban, medium dense urban, low dense urban. So creation of signature file becomes the first step. Second is to perform the supervised classification, and the input is the image, that is the satellite image, or you can subset the image, an area on which you need classification. When I'm saying subsetting the image, it is also essential because sometimes what happens, we are only concerned about the planning area boundary, or we are concerned about the metropolitan area boundary, or we are concerned about the block area boundary. So we can subset the satellite imagery and we can extract only our area of interest, that is the planning area boundary or the metropolitan area boundary, and perform the classification schema on that. And the input will be your image, the subsetted image and the referenced image, and the signature file. Okay, when I say referenced image, it is also essential to understand that there are coordinates attached to every satellite image. So georeferencing, if not provided, has to be provided to the image. However, all images come with georeferencing. If not, if you have to change the georeferencing system, you can change it by reprojection. Now, different algorithms are available for the classification. Maximum likelihood, parallel piped, minimum distance. We generally used maximum likelihood. Maximum likelihood tells us the probability of the pixel of belonging to that category and can be changed to a certain class. Unsupervised classification, as I had already said, that no prior knowledge is required. So user have to give only one input, that the entire image, the entire input satellite image will, after the output, will have how many classes. So we have to define beforehand. So for example, a standard classification will have 6 classes, 5 or 6 classes, or 7 classes at max. So in unsupervised classification, you can give maybe 50 classes, and later when the unsupervised classification image comes to you, you can club the classes together to reduce the number of classes to 5 or 6. So supervised classification, an example that this is done on Dehradun area for different years to 1998, 2003, 8 and 13 at an interval of 5 years, and red color shows the built up. Now we can evidently see that the built up has increased from 1998 to 2013, and the boundary that I have taken is the planning area boundary. So we were concerned to understand that in Dehradun city, in the planning area, within the master plan area of the city, how much has the built up grown from 1998 till date. So this is the kind of analysis. So after supervised classification, because I had knowledge of Dehradun area, I had chosen pixel based supervised classification, and then I came to a conclusion that the city has tremendously grown from 1998 to 2013. Now, there are different softwares available which will help you in doing this pixel based classification. After classification, you can do analysis. Analysis of which form? You can analyze the different year data, and you can make pie charts, and you can have Excel charts to understand the different growth scenarios. You can also understand by providing a windrows diagram that how the city has grown and in which direction the city has grown. So there is a approximately 29% growth from 2008 to 2013 in Dehradun city, and the city has grown typically in three major directions, which is northeast, west and southeast. So this kind of analysis and how much it has grown, that can also be analyzed with the data. Now this was another study in Haridwar area. The planning area boundary was not chosen. It was an initial study, and two data sets of Landsat and List 3 were taken. Now I have specifically put this two data because of two reasons. Number one, you can also do the analysis on a typical area without having a planning area boundary. There are many areas within India, many cities within India, which have grown tremendously outside the planning area boundary as well. So if you do not have the planning area boundary, you can only choose one area, a rectangular area, subset the entire image and do the classification on that image. Now, why I say that you subset the image, because the satellite imagery which comes to you is too large. You cannot subsetted imagery. Another reason for choosing this slide was that we have chosen two different sensors. We have chosen Landsat imagery and we have chosen List 3 imagery. Now, Landsat imagery is at 30 meter spatial resolution. However, List 3 imagery is at 23.5 meter spatial resolution. So how are we going to compare the two? So what we can do is we can resample the 23.5 meter to 30 meter, and then it becomes comparable, and then it can be used for analysis and comparison. So LULC area comparisons. Now this kind of area comparisons can be made. The different classes which were there, okay, here it is not visible. Probably here you can see the classes that are defined for 2000 and 2009: water body, dry sand, dense forest, then we have forest, built up, agriculture and fallow land, and a total area. So on these 7 categories, we have divided the total area. This is Haridwar region, and this kind of analysis can be made. All planners understand this kind of analysis, that how the LULC change has occurred. At this point, I would also like to mention that Bhuvan is a very important and prominent platform where you have land use, land cover change maps also available on Bhuvan platform. So bhuvan.nrsc.gov.in, you can log in by your username and password, or get registered and then log in, and you can see the various land use maps of different cities. So for your information, you can bring these layers by WMS server, that is web map service, into your platform, GIS platform like QGIS, which is an open source platform, or ArcGIS, whichever is available with us, with you, and you can digitize over it. All the layers are not downloadable as shapefile, so you will perhaps have to do a little more mehnat and digitize over it. So this kind of change maps can also be made. Change detection is a tool which is available on almost all image processing softwares, and you can do the change analysis also. What do I mean by change analysis? That how much built up has grown, number one, which class has changed to which class. So for example, dense forest has changed to built up. So how much it has changed and what area has changed, that kind of analysis can also be done. This is important in the sense that we need to understand that how much are we depleting our own natural resources, and we need to understand, and hence for that we can have such kind of analysis, change map analysis. Next, coming on to object-based classification. As I had explained that object-based image analysis or image segmentation is one area of fuzzy classification, where you can see in the image below that we have pixel-based classification and we have object-based classification. In object-based classification, we have various factors, for example, shape factor, then we have compactness factor, and pixel, the pixel spectral value also sometimes play a role. So all these factors together help in identifying objects. So here we are not having each pixel being assigned a value, we are having group of pixels being assigned a class because it becomes an object. Second problem, when I said that a panchromatic image and a multispectral image can be merged together, for a supervised classification or pixel-based classification, you cannot perform classification on such kind of imagery because the pixel values or the spectral values change. So what we can do is we can go for object-based classification analysis, because even if fused image we are using in object-based classification, it is not going to make much difference or problem. It is not going to make any problem. So the same process follows. We have the satellite imagery, images being pre-processed, then you do image segmentation based on certain rules. We do object-based image analysis, we classify the image, and subsequently we do the accuracy assessment. So we are coming to the end of the lecture by understanding that how we do accuracy assessment and why is this process so important. See, the system or the computer or the software is doing a process for us, and it is doing the process based on some a priori knowledge which we are providing to it in the form of training sets. Otherwise, it is performing based on the pixel values or certain set of rules which we are providing in object-based image analysis. So these three kind of inputs we are providing, and it is giving us the output. Now, how do we say that on ground this pixel belongs to urban only, or what we have obtained as a classified image, it is the correct classification schema or not? So for that we go for accuracy assessment. Now there are various techniques of doing accuracy assessment. Kappa statistics is the most famous of all. So how do we understand that this particular image has been classified correctly, or what is the percentage accuracy? So for that we prepare a confusion matrix or a error matrix or a contingency table. So different names are given to the table. Confusion matrix being the most widely used, error matrix being the second most widely used. So what is it going to tell you? It is going to tell you the relationship between the known reference data and the corresponding results of an automated classification. So after the classification, this type of image comes to you. The kappa statistics, that what is the overall accuracy? 0.9. It ranges from 0 to 1. So if more than, as I told initially in the lecture, if it is the overall accuracy is more than 85%, it is considered to be a good classification. That means misclassified pixels are less and the classified is a good classification. If it is not a good classification, if your accuracy is falling below 85%, then you can go for reclassification of the imagery. And this confusion matrix is automatically created on the web. However, you can make, on the software, you can also make it by hand. So with this, I come to the end of the lecture, and thank you so much.